Hello, everyone. Welcome to the course Photography Exposure and Lighting Technique. Today, we will cover the fundamental concept of exposure aperture, shutter speed, and ISO. Put simply, exposure refers to how bright or dark the image appears. It is controlled by ISO, shutter speed, and aperture. Since all three can influence brightness, how do they differ? Let's start with aperture. Aperture is usually denoted by f. The larger the number after f, the smaller the aperture opening, the less light enters, and the darker the photo. Conversely, the smaller the number after f, the larger the opening, the more light, and the brighter the image. So, what does aperture do? 1. It determines how much light the lens lets in. The smaller the f number, the larger the aperture and the more light. The reverse is also true. In short, if shutter speed remains constant, a smaller f number larger aperture yields more light and a brighter image, while a larger f number smaller aperture yields less light and a darker image. 2. Aperture is the primary factor controlling depth of field. A small aperture, large f number gives deep depth of field, while a large aperture, small f number gives shallow depth of field. For example, nearsighted people who squint to see clearly without glasses are, in photographic terms, stopping down the aperture pupil to increase depth of field. See figure. Large apertures include f1.2, f1.4, f2.8, etc. f5.6, f7.1, f8.0 are mid-range. Anything above f9.0 is considered small. To render creamy background blurring portraits, use f2.8 or wider. For landscapes, photographers typically choose small apertures like f11 to f32. Based on the above, we can summarize aperture size with shutter speed held constant. The smaller the f number, the larger the aperture, the more light, the brighter the image, the narrower the plane of focus, and the greater the background blur. The larger the f number, the smaller the aperture, the less light, the darker the image, the wider the plane of focus, and the sharper the foreground and background. We can use aperture priority mode on or off. We set the desired aperture, and the camera automatically adjusts shutter speed for correct exposure based on scene brightness. Aperture priority lets us control both shutter speed indirectly and depth of field directly, offering great creative flexibility. The flower images below demonstrate how a large aperture yields shallow depth of field, while a small aperture yields deep depth of field. Aperture priority suits portraiture, landscapes, night scenes, macro, and any subject where depth of field is critical, but it is less ideal when precise shutter speed control is required. Besides affecting light intake, aperture size influences other imaging characteristics. Do shutter speed and ISO have effects beyond brightness? Absolutely. The shutter is the mechanism that controls how long the sensor is exposed to light. The principle is simple. Imagine a faucet turned fully on for 5 seconds will collect half as much water as one left open for 10. If the basin is the camera sensor and the faucet's diameter is the aperture, then the duration it stays open is the shutter speed. Shutter speed is expressed in fractions of a second. The slower the speed, the more light enters larger denominator. The faster, the less light smaller denominator. The value itself indicates the open time in seconds, e.g. 1/100 means 1/100 second. The imaging effects are illustrated below. Freeze moving subjects. We need a sufficiently high shutter speed, otherwise we record motion blur. The faster the subject, the higher the required shutter speed. For a 50mm lens, the safe shutter speed is 1/50th second or faster, though this is only a rule of thumb. Optical stabilization, personal steadiness, wind, and other factors altered. Cameras also offer shutter priority mode TV or S. Advantages of using shutter priority. 1. Use high shutter speeds to freeze motion. For example, athletes or speeding cars. 2. Use slow shutter speeds for creative blur. For example, silky waterfalls Dolai ISO. In digital cameras, can be understood as electronically amplifying the signal like a website boosting video volume to 200% or 300%. Excessive amplification introduces obvious noise. Raising ISO brightens the image, but increases noise. Post-processing can reduce noise. Yet overall image quality still degrades, because noise reduction algorithms essentially smear pixels, harming sharpness, detail, and color fidelity. Let's recap how the three exposure elements affect brightness. The basic principle is that aperture, shutter speed, and ISO together control image brightness. With ISO and shutter speed held constant, opening the aperture by one stop doubles the incident light, increasing exposure. Stopping down reduces light geometrically, darkening the image. With ISO and aperture fixed, lengthening shutter speed by one stop doubles exposure. Shortening it halves the exposure. With aperture and shutter speed unchanged. Raising ISO by one stop doubles the effective light. Brightening the image. Noise increases accordingly. Conversely, lowering ISO halves effective light. Image quality reaches its optimum. To achieve the same brightness with a fixed aperture, the faster the shutter speed, the higher the ISO needed. With shutter speed fixed, the larger the aperture, the lower the ISO required for equal brightness. With ISO fixed, the larger the aperture, the faster the shutter speed can be. That concludes this section. Thank you.